So we've got this request from a customer, and what they're telling us is they've got a space and power problem in a data centre. And they're asking us what the potential impact of virtualisation on that estate might be. What sort of things should we be taking back to them?
Virtualisation is a great deal of benefit in doing so, and consolidating your compute onto a smaller number of servers. But what you must consider, obviously, when you do that is that you're also creating a higher level of density and driving those servers a lot harder. So as you plan to reduce the amount of space and the number of servers you actually base your infrastructure on through virtualization, then you must also consider which type of servers you base that on, so you can then address the power and heat issues that are brought about by consolidating into a smaller footprint. You have the same space, but you've got to look at the impact of the infrastructure. So critically, you're going to run the servers hotter, you're going to run a lot less, you're going to run higher density compute, so you're going to end up with a hotspot in a data center. The type of server and the design of server that you actually use to implement your architectural change from a physical to a virtual is then going to be critical.
Okay, so assuming that they're going to say, right, virtualization is the target, which would be a sensible first move in terms of reducing space. And we're talking about, okay, the choice of servers is important. What sort of attributes should they be looking for in the servers, and more specifically, how can we tell them that those attributes are important and Fujitsu actually understand those attributes?
So principally, they need to look at the way the product was designed to actually deliver on the virtualization promise. They need to understand that as you consolidate onto a platform, then you need to know to understand it's critically more important that that product's going to deliver. It's going to stay stable under much higher workload conditions than historically delivered by industry standard servers. There are also other bottlenecks such as I/O, heat and ambient temperature and temperature control, and the way that temperature is being managed also at a management layer. So in other words, your server management suite delivers and plays an more important part in the way you manage your infrastructure. So notionally, Fujitsu are the only organization that redesigned their platform infrastructure, Primergy, to deliver virtualization architectures. We're the only ones that implemented the full breadth of capability from Intel's NALM implementation, NALM EX implementation, and we also redesigned our blade chassis structure to deliver on the virtualization promise. So what does that actually mean? It means that we've implemented by design architectures that will make sure that the product is more reliable under higher workloads, run more efficiently, at least 20% on average compared to most industry standard servers available today, and also provide other additional benefits such as increased I/O through implementations of such things as VMDQ on the Intel architecture chipset for networking. So that basically means that you're reducing the overall impact on the data center in terms of heat, because you're making it dense. You're making those servers run more reliably because you're reducing the amount of power and the power quotient. You're cooling those servers more efficiently, and then you're also looking at the ancillary effects of virtualizing dense virtual machines and the I/O complications that result from that.
So does that mean by using a Fujitsu Primergy server range, I can actually get better virtualization ratios and more compact data centers?
Virtualization ratios are really governed by application workload as well as capability and processors. But what you will be able to do is actually ensure that the expected outcomes, which is the key thing, the expected outcomes and the promise of virtualization, the service levels that you provide are much more stable, and there would be less risk, or you're de-risking the overall implementation of your infrastructure. So the likelihood of failure through overheating, the likelihood of stepping down through overheating on the processor, which will result in a service level impact, and also mitigating bottlenecks through the I/O layer on, for instance, specific things like virtual machine density through I/O.
So we could quite confidently say to this customer that the Primergy servers have been designed to take a higher payload for longer, more reliably.
They've been designed for virtualization in mind. So they deliver a much more stable platform to look at delivering now and into the future higher payloads from virtual machine architecture.
So in principle, what you're saying is that using Fujitsu primary servers actually may have an impact on the number of servers they need because of the high consolidation ratios.
Absolutely, Chris. What I'm saying is that you're going to be able to create a much more stable infrastructure, gain the benefits of that stability, the overall cooling quotient, the efficiency and power. You might actually be able to increase the number of or reduce the number of servers because you're getting a 20% efficiency over improvement on other industry standard servers. But at whichever level, even if you went on par, you would be able to more guarantee the promise of the physical to virtual transformation project. So in other words, if you look at it just in line, you'll get benefits in power saving, but you also get benefits in the reliability and the stability of the overall infrastructure on Fujitsu product.